LS574 basic search commands. Today we're going to see the basic search commands for searching online databases. Of course, we're going to focus on academic databases. Let's start with the Boolean operators, or what is called the Boolean logic. There are three basic operators: and, or, and not. Okay, and the idea with the basic these three basic operators is combining them to make either our search to have more recall or more precision. We can also combine terms in different when we do field searching, and later in today's lecture I'm going to show you that using one of the databases that we have available at Clarendon University. The first basic operator is and what it means is that when you combine two terms, for example A and B, and you do the operator AND is A and B, you will retrieve a set that has both terms A and B, and we're going to see in the next slide, we're going to see this in a graphical way. For example, I want documents that have both terms apples and orange. So what I would do in my search, I would combine both terms, apple and orange, with the operator AND. The second operator is OR, either the one or the other or both. And for example, A or B retrieve a set that has either A, B, or both. So as we can see right from the beginning, if we use AND, we would be searching for more precision. If we use OR, we would be searching for more recall. Of course, the idea is that we can combine AND, OR, and the third one that is not. An example of OR is I want documents that have either term apple and orange, or both terms together. So we will be retrieving documents that have apple as a term, orange as a term, and documents that have apple and orange too. So we will retrieving more documents. The third one is not, and the syntax is A, not V. We will retrieve a set A but not B. For example, I want documents that have the term apple but not having the term orange. So we only will retrieve documents with the term apple, but we won't retrieve documents that have the term orange in it. Okay. Another example would be, for example, if we want to retrieve, if we combine pets and dogs, but we don't want cats, so we can combine, for example, pets and dogs, not cats. That means that we will retrieve documents with pets and dogs, but not with cats. But we will retrieve other type of pets, okay, but not cats. So let's see this in a graphical way. Okay, here we have the Venn diagrams, and this is how we apply the Boolean algebra for searching. In this example, we have information retrieval, okay, and we have A and B. A information, B equals retrieval, and then we have the Venn diagrams 1, 2, and 3 right here. Okay, so A, if we retrieve A by itself, information, we will retrieving all documents that have information as a keyword or descriptor, in whichever field we're using that term. And as I said before, we're going to see that a little bit later when we get into one of the databases. So if we use if we use the term information, we will be retrieving number 1 and number 2 right here. Okay, because information as a keyword in this case will be in all of those documents. Now, if we combine A and B, meaning information and retrieval, we are going to retrieve documents, or we're going to recover documents that have both terms. So in this case, we will be retrieving only number 2. Why? Because we are combining 1 and 3, or to be more clear, we will be combining information and retrieval. Okay. What about if we use that operator or, and this is the third one right here. Well, if we use A or B, we will be retrieving 1, 2, and 3 because we're going to say information or retrieval. So we will be recovering all the documents that have information, all the documents that have retrieval as a keyword, and all documents that have information and retrieval. So this will be a high recall search. And we can use, of course, the operator not. What about if we use A, not B? In other words, information, not retrieval. Well, then we're gonna retrieve less documents because what we will retrieve will be number 1 only. Here, number 1. This means A, not V. If we go the other way around, V, not A, then we will be retrieving number 3 only. Okay, so we will retrieve less documents. This is your basic Boolean operators, and it's a very effective and efficient way to search databases. Here we have a more complex example on how to combine the Boolean operators in our search. We have 3 terms: A, information; B, retrieval; and C, online. And we are combining them using parentheses. Okay, in the first example, A or B, meaning we're going to retrieve all information, and B, all retrieval. So it means this whole area right here. So we will be retrieving 1, 2, 3, 4, 5, and 6. Okay. Now, what about if we say A or B, not C? Okay. So in this case, we will be retrieving 1, 2, and 3, but we will not be retrieving C, this space right here, 4, 5, 6, and 7. If we say A and B, and that's the first operation because remember it's in parentheses, A and B, we will be retrieving documents in 2 and 5 right here. Not C. Okay, so we have to take off the number 5. So we will be retrieving only documents in 2. Okay, and so on. So there are many ways that you can combine Boolean operators. One thing that you have to understand, and I think I mentioned this before, is you have to use parentheses, because when you use parentheses, that's what the computer in their search is going to do first. There are also proximity operators, and this may change in each database. So as I have mentioned in the past and in my other lectures, you always have to look for the help file. And in our homework with the 3 search engines, look for the search for the help file. Why? Because it's going to give you the instructions for the specific database. Not all databases, not all search engines are created equal. Here we have an example using the proximity operators, and this is when you use proximity operators, you're going to look for words that are adjacent and to the term that you are looking for. Okay, so you may use for example NW, and that means that you're going to search in words that are 2 words out of the search terms. If you use N, words adjacent in either order, so they can be before or after. Okay, so these are examples of proximity operators, and we're going to see these in a few minutes. in a database. S, words that in the full same subfield unit as defined by the database in full text files requests that terms be in the same paragraph. So you want terms to be in the same paragraph. L, words in the same descriptor unit as defined by the database, headings, subheadings, entries, etc. For example, solar, L energy. F, terms should be in the same field as defined by database. Example, in the title or in the abstract. So you have solar and F cell. Both terms should be in the same field. Also, you can add not before these proximity operators. For example, search not W engine. This command to retrieve all occurrences of search when not followed by engine. So in this case, you're combining the proximity operator with the Boolean operator not, and you're going to retrieve search that are not the documents that have the word search that are not followed by engine. This again would be a very high precision search. Okay. We can combine these operators in a search command. For example, search, engine, and to-end library. We can use logical operators to combine proximity operators and search terms. So we can use Boolean logic and we can use proximity operators, okay? And this again will yield a high precision search. One example, for example, would be search engine and information retrieval, okay? Again, every database is different. So the idea here is that when you have to become familiar with the database that you are going to use. And I'm going to show you how you're going to do that. This is order of execution, and this is as I mentioned before, this is very important, and that's why you have to put into the expression in parentheses. Here it says this is a critical issue, just like in ordinary algebra. For an expression 2 plus 3 times 5, you should compute the multiplication before the sum. In Boolean expression, you also need to consider order of execution of different operators. In other words, in order to do that, if you have a command driven search, you use parentheses. If you are using a database with a graphic interface, then you will go by order from the top to the bottom, and we'll see that in a minute. Truncation, and wildcards, that's also very important for our search to make it more efficient and more effective. Truncation allows you to search on a word stem and retrieve any word beginning with those letters. Again, it will vary from vendor to vendor, from database to database. For example, in the dialog system, truncation mark, question mark, is used, and there are 3 types. If you use open truncation, you use the question mark at the end, for example, library, and then the question mark. All terms that have that beginning, LIVRAR, should be included, such as library, libraries, librarian, librarians, and so on. And you will be able to retrieve all of those documents with that term. You can restrict truncation, for example, cat, and you will be retrieving cat, cats, etc. Then you will have, for example, plants, planting, but you won't be able to retrieve plantations. Internal truncation, and this also is called a wildcard, because you don't know the correct spelling and you don't know if you're looking for a singular or a plural. So you can use in dialog, you can use this interrogation sign to retrieve terms that have all the same letters, but the one where you have put the wildcard or the truncation. There are stop words, and it's also an important concept in information retrieval for some words which are frequently used in documents but have no meaning. in your search. Okay, why? Because most information retrieval systems do not index them. Some of them are A and D of and so on. For example, there are 9 stop words in the dialog system, and, by, for, from, one, of, the, to, and with. So you don't use them to search. And when using them as a search term, you have to use a quotation mark for words, and or files select from steps not. This is of course different from Google, because when you use it with Google, the search, you use quotation mark with what is in between the quotation marks. Google will take it as a phrase. And now let's go and see some examples. Here we have this is Academic Search Complete. By the way, you can choose your database here. Let's see how this works. I got this through the, of course, the Clarion library website. We can choose databases here. Let's choose you can select all here, or you can select, in this case, let's select library, literature, information and science full text, and library, information, science and technology abstracts. We're going to select these two in our area. We click OK, and now we are working with our own database. Let's go to the basic search first. Normally, most of patrons and students will use the basic search. Okay. The problem with the basic search is that you can do several terms here, and they will be combined. For example, it says what kind of search do you want to do, such as a Boolean phrase, and that's fine. But in my opinion, you cannot do. It's not enough to have a precision, because you cannot do field search. So I always recommend that you go to the advanced search. So we click here in advanced search, and here we have advanced search. If we see here in these windows, we have the Boolean operators here, and, or, and not. And even though we have 3 rows here, it doesn't mean that we only have to use 3 rows. We can add more rows if we click right here. You see? Or we can remove rows. And here then we can combine terms. But the advanced search gives you the advantage that you not only can combine terms, but you can select fields. So this will make for a very efficient and effective search. If you don't know exactly, because you only have one part of a word, you may search all text. If you have a last name, you may search author. You may search title, subject terms, source, meaning the journal name. You may search for a keyword in the abstract, and if you have the serial number, you can search by serial number. And the idea here is that you use the search boxes, combining with the Boolean operators and using field text. Okay, field search. I'm sorry. You can also, as you see here, you can also limit your results. Okay, by full text, scholarly, peer-reviewed journals, or date, or images, and publication type. You want to search academic journals, books, periodicals, etc. Also within those, you can search different type of documents type. For example, if it's a letter, if it's a research paper, case study, etc. So these are all options that we have when we do search, and we're looking for precision. Here we have in the second database, in the abstract, we can search by document type, article, bibliography, etc. And here we have, even we can do our search, we limit our search by language. Again, each database is different, So we have to understand how each one works. And one way to understand that is going to the help file. The help file is right here. Okay, so we click in the help file and we have here instructions on how to be an efficient and an effective searcher. We saw I talk about some things like wildcards, truncation, proximity operators, etc. in the PowerPoint, but we have to be specific for each database, and we will find examples here. For example, we have instructions on how to perform a basic search and how to use the limits, etc. But if we want to go to, for example, let's go here, booleans, and here the help file will explain to you or to your patron how do you combine the Boolean operators. Here we have and, for example, and let me highlight and, combines search terms so that each search term results containing all of the terms. For example, travel and Europe, find articles that contain both travel and Europe. A lot of precision. Now or, a lot of recall. Or combines search terms so that each search result contains at least one of the terms. For example, college or university, finds result that contains either college and university. And finally, the not operator here exclude terms so that each search result does not contain any of the terms that follow it. For example, television, not cable. Find results that contain television but not cable. And here we have a table that illustrates how to use Boolean operators. This is very important too, and this is the syntax that I was mentioning before in the PowerPoint. And here it says, to make even better use of Boolean operators, you can use parentheses to nest query terms within other query terms. You can enclose search terms and their operators in parentheses to specify the order in which they are interpreted. Okay, so again, if we are going to make a search, we in this database, and we want to nest terms, it's always a good idea, as it is saying in the help file, to use parentheses. And here we have one example. When you enter mouse or rat and trap, the search engine retrieves results containing the word mouse or the word rat together with the word trap in the search field. So here we're telling exactly to the search what do we want to do. Okay. Now let me see what else we have. Oh, expanders. This is also very important. Expanders let you broaden the scope of your search. They do this by widening your search. Recall to include words related to your keyword or including the actual text of the full text results in your search. Common expanders that can appear below the refined search subtab include apply related words. We can click that option, select this option to expand results to include true synonyms and plurals of your term. So here we are expanding our search. We are recalling more documents. Okay, so we can use expanders in our search. Let me see what else we have here. Okay, proximity searches. In the PowerPoint, we went through proximity searches, but these are specific for this database. And the database we are exploring here, or the vendor, the provider is Academic Search Complete, and we are using, for in this case, library literature and information full text, and the other, let me show here, and library information science and technology abstracts. Of course, this provider, EBSCO, uses, in almost all of their products, uses the same structure. Okay, so but in any case, it's always a good idea to go to the help file. Okay, let me see where my help file went. Okay, right here. Okay, so here we have the help file, and this is in terms of proximity operators. Again, this vendor, EBSCO, will have almost the same structure for all their academic databases. However, in my opinion, we always have to go to the help file to see how it works. And when we want to use proximity searchers, are very efficient too. You can use a proximity search to search for 2 or more words that occur within a specific number of words or fewer for each other in the database. Proximity searching is used with a keyword or Boolean search. And let's see how it works. The proximity operators are composed of a letter, N or W, and a number to specify the number of words. The proximity operator is placed between the words that are to be searched. For example, near operator, N5, finds the words if they are within 5 words of one another, regardless of the order in which they appear. In other words, they may appear at the front, before or after. For example, if you type tax N5 reform to find results that which match tax reform as well as tax reform of tax income tax. You see, it's not next to it, it has 2 words in the middle, but still you will be retrieving that document. The other one is the W, within operator. In the following example, W8 find words if they are within A words of one another and in the order in which you have entered them. For example, you type tax W8 reform to find results that would match tax reform but would not match reform of tax income tax. Why? Because they are within A words and in the order in which you enter there. So you can see the difference, the near operator and the within operator. Okay, again, and this is my word of advice. This is something that you yourself have to practice when you become a reference librarian and you become familiar with the different providers of database such as EBSCO, etc. You have to understand what the logic and the structure are in order to be a proficient and efficient searcher. Let's see what else they have here. Then we have wildcard and truncation, and also it was pointed out in the PowerPoint, though I didn't stop too much in proximity and wildcards. Why? Because in my opinion, this is again specific to each vendor and to each database. So we have to go to the product and see what they tell us about the wildcard and truncation. In the PowerPoint, I said that the dialog used a question mark. Let's see what they use here. You use the wildcard and truncation symbols to create searches where there are unknown characters, multiple spellings, or various endings. Neither the wildcard nor the truncation symbol can be used as a first character in a search term. So you cannot use the wildcard or the truncation as your first letter or character in a search term. They have to be in within the word, the search term. The wildcard is represented by a question mark, okay, that's similar to dialog, and by a pound sign, okay. And so we have here two characters, the question mark and the pound sign. Now let's see how they work. To use the question mark wildcard, enter your search term and replace each unknown character for a question with a question mark. Okay. For example, type net ne question mark t to find all citations containing need next. Okay. This will be very effective. For example, if we are looking for a name, for a last name, we have an author's last name, but we don't know the right spelling. So we can use a wildcard. Okay, when searching for a title that ends in a question mark, the symbol should be removed from the search in order to ensure results will be returned. So you see, that's when if you're searching the field title, you don't use the question mark. Use the wildcard. Now we have the pound symbol here to enter your search terms, adding the pound signs, the pound sign in places where an alternate spelling may contain an extra character. And here we have an example, because this spelling may be the English or the British and the American way to spell color. You see? So this is very interesting too. And truncation, we use an asterisk. To use truncation, enter the root of a search term, replace the ending by a asterisk. For example, type compute and we put the asterisk here, and to find words computer or computing. Oh, the truncation symbol may also be used between words to match any word. Okay, for example, we're looking for this title and we don't know what the word in the middle is, so we just remember a midsummer and we use the asterisk and we put dream, and we will retrieve a midsummer's night's dream. Remember when we had in one of the homeworks we only have part of the citation? Well, maybe a good idea to find the document was to use a truncation symbol, or maybe it was a good idea to use a wildcard, or maybe etc. etc. So we have to get familiar with the choices that the vendors provide in database search. Okay. So I just wanted to make sure that you understand that that we have many choices, and they may differ a little bit from each of the providers. However, once we understand the basic concepts, it will be very easy to understand how to use them. So for basic search, we have to understand Boolean operators. We have to understand expanders. We have to understand proximity searches. We have to understand wildcard and truncation. These are the part of our toolbox as searches. And of course, it will be very relevant if we are going to become reference librarians. I was a reference librarian for many years, and I knew I always I became familiar with some databases because it made my work easier. I know that there are people that have the opinion that, okay, first I will search Google and then, okay, it doesn't matter how you get to the result. The thing is that you have to realize that knowing all the tools, you have to know all the tools that are available to you to make out of yourself a better searcher. And we're going to see that later, but just let me put back the database here, the EBSCO database. We have subjects, and we have a thesaurus here. Okay, so like we are using two databases: Library Literature Information Science Full Text by Wilson, and we are using Library and Information Science Technology, and both have a thesaurus. Okay, and we're going to talk about thesaurus usage later. And another very important thing is the index. Okay, both had an index. Okay, and that's also important to use when we want to do a professional search. And of course, please don't ever forget the advanced search and combining Boolean operators right here with fields. In the case of this vendor and this database, it is on these two databases that we are working with. There are only let me see how many searchable fields there are. 1, 2, 3, 4, 5, 6, 7. There are other databases that may have you may have access to more fields, and there are some others that have less. You will have less fields available for searching. The idea again is that we become familiar with searching, that we become experts, because these are our tools, and we have to be proficient and better searchers than anybody else if we want to do a good job. Okay, thank you.